for this one, for the next section, we're going to go to doing the graphic organizer for quadrilaterals. For that, we're going to start off with quadrilaterals up here. Since they're the most broad of all the four-sided polygons. And then we're going to add what are the defining characteristics. So four-sided, or four sides, and the interior angle sum has to be 360 degrees. From there, it can branch off according to how many sides are parallel. And 0 pairs of parallel sides. Again, remember the two vertical bars right by each other mean parallel. So 2 pairs of parallel, or 0 pairs of parallel sides. The only special one that I have for you guys is what we call a kite. And a kite has 3 factors. I'm going to write them off to the side because they get kind of long. So, 1, first factor for a kite is that exactly 1 diagonal bisects a pair of opposite angles. Second defining characteristic is that there is exactly 1 pair of equal opposite angles. And if there were 2 pairs, then we'll find out that that will give us a parallelogram. And the third one is the one that gets kind of wordy. And in some way you need to say that there's 1 pair of adjacent sides that are equal, that is different than another pair of equal adjacent sides. So these 2 down here are different than the top 2. Okay, I'm going to move over to 1 pair of parallel lines, and this is a defining characteristic of trapezoids. So those 2 are parallel, and since I put the defining characteristic along the line, I'm just not going to put it inside the shape. For a parallelogram, which is the next category, a parallelogram has 2 pairs of parallel sides. It has 2 pairs of equal opposite angles. it has two pairs of equal opposite sides. So those are kind of the three that go together, the two-pair group. And then there's two more. We know that both consecutive angles have to be supplementary. Again, supplementary meaning adding to be 180. And the last one is that the diagonals bisect each other. That is, all of these, all five of these, are true for any parallelogram. So these five characteristics will apply to every single shape that is underneath of the parallelogram as well. And this can branch off then into two groups. First group is what I'm going to have is the rectangle. The rectangle, its defining characteristic, one that has four right angles, or it could be that you prove that it's a parallelogram and then you show that it has one right angle. And the second one is that if you prove it's a parallelogram and that the diagonals are congruent. Okay. Other group. It's not drawn very well, but I will mark it so that way we know that all of them are equal. This is a rhombus. R-H-O-M-B-U-S. And a rhombus, all sides are equal, as I marked. And the diagonals bisect. I'm going to write it off to the side. The diagonals bisect a pair of opposite angles. The difference between a rhombus and a kite in this matter is that both diagonals have to bisect a pair of opposite angles. Then a rhombus and a rectangle come together to form a square. A square then, of course, is typically thought of 90 degrees, 490 degrees, and four sides that are equal. But those are just characteristics of rectangle and rhombus. So we just need to say that it needs to be proven that it's a rectangle and a rhombus. And that is it for the defining characteristics and the graphing organizer. Now you could use this and you could do our always, sometimes, never. We could say a quadrilateral is a kite. Is that always true, sometimes true, or never true? And that would be sometimes true because it is a kite is a quadrilateral, so that would be an example of when it would be true. But it doesn't have to be a or it doesn't have to be a kite. It could be a parallelogram. It could be a trapezoid, or it could just be a regular, or it could be just a quadrilateral with nothing special about it. Another example would be a rhombus is a parallelogram. A rhombus fits underneath of a parallelogram. It has all the characteristics of a parallelogram, so therefore it will always be a parallelogram. So that would be always true. I could say a rectangle is a trapezoid. and that would be never true, because a rectangle is under the parallelogram, which means that it has to have two pairs of parallel sides, and a trapezoid only has one. So therefore, a rectangle and a trapezoid will never be the same. These are examples of what types of questions could come up on a test. That is it for this section, and part 2.